Hello, I am Dr. Jennifer Ripley, and this is a short mini lecture on the topic of correlation coefficients. We're going to try to cover four things in this mini lecture. First is, how do you know what significance means when you're in the land of correlation coefficient? It's a different land than t-test and ANOVA, where you're comparing groups. We are now in a new area looking at all continuous variables. How do you interpret a correlation coefficient? What does it mean? Also, can you distinguish between significance and meaningfulness? And this is a really important thing. And then we'll do a little bit of SPSS to look at correlational data as a simple analysis. For this lecture, we're primarily drawing from Statistics for People Who Think They Hate Statistics by Salkind and Frey. And back in chapter 5 of that textbook, you learned how to calculate a correlation coefficient to determine the relationship between two variables. And so you had an introduction in chapter 5. We are now later in the book, and we are talking about how we know if correlations are meaningful, what they are all about, and what they can tell us. We need to be able to look at the data and interpret it correctly, because while computers can do a great job of analyzing data, only our minds and knowledge base can be used to make meaning or understanding of all the data we look at, including correlations. So if you think back and remember, correlation just means that there's a relationship between two continuous variables. They do have to be continuous variables. They cannot be categorical variables with a regular correlation anyway. There are some special versions of correlation you can do that will get you to unusual ways, as statisticians always create all kinds of alternative things. But the typical Pearson's correlation that you use in statistics and psychology is just looking at the relationship between two continuous variables. Remember that correlation does not mean causation. This is one of the oldest sayings in psychology. I hope you've heard it many times before now, but I just want to clear the cobwebs and help you think. Yes, it's true. When two things correlate with each other, you can't tell whether A produced B or B produced A, right? Or whether some third variable produced both of them. It's entirely possible. It's like the old joke about in a city, you find a correlation between the number of bars and the number of churches. And what is causing what? Is it possible that the bars cause churches, right? And you can kind of come up with a story in your mind as to why you think bars might cause churches, or why you think churches might cause bars, right? Where the flip of the relationship. But in actuality, most likely, it's the number of people or the population size that causes both the number of bars and the number of churches. So you really do have to be careful, because our minds go looking for causation. That's the way our brains work, and we need to make sure that we don't think beyond the statistics that we have. We can use correlation, though, as a magnitude measure to examine the strength of the relationship. And that is the language that's used in correlation and regression land, is what is the strength or the magnitude of the relationship? That's the important question. Your correlations are going to range from -1 to 1. If you ever see a correlation written down outside of that range, there was something terribly wrong that happened there. And the textbook uses the term direct and indirect relationships for positive and negative correlation. So just be aware of the new language for you. If that's new language for you, I tend to be more direct in my own language and say positive and negative correlations specifically. But remember that positive correlations, when one goes up, the other one goes up. When one goes down, the other goes down. And an indirect or negative correlation is like a seesaw. When one goes up, the other one goes down, and vice versa. So you're going to want to pay attention to that positive and negative sign. It's really important in correlations. Now, one of the most important things to remember, and you'll hear it repeated over and over in the textbook and in my work with you guys, is that just because two variables are related to each other does not mean that one thing causes the other. You can have many explanations as to why, just like the bars and the churches example. You can think of 50 other explanations about why. So let me give you another example. There is actually a correlation between the number of pirates in the world and the temperature, the global temperature. So I recently listened to a really good explanation of this. But you can sit there and try to kind of make sense of it, right? As global temperatures go up, pirates go up. That could be it. Maybe as the number of pirates goes up, the global temperature goes up. That seems unlikely. But actually, what they think is happening is there's some third variable because when the temperature went up, that the number of hurricanes went down. And so, because the number of hurricanes changed, you have more pirates because there's less hurricanes in the ocean. So, you have more pirates that are able to get around. It's a more lucrative business, right? You're able to avoid the few hurricanes that do exist. And in fact, there was a time in the 1800s apparently where there were hardly any hurricanes all year, which seems so strange right now for us. But there's lots of explanations. And so when you're looking at correlations, remember that it's much more like a descriptive data that you're looking at. It's a more basic data. It is generally not testing a hypothesis like a real research study does. You're really just exploring your data with correlations, or you're examining maybe assumptions of larger correlation or larger research studies that you're trying to look at for an actual hypothesis testing. I just wanted to walk us through figure 15.1 from your Salkind textbook because I think it has some good information here to help you to think like a statistician and to be able to evaluate research. So you'll start there in the top left corner where it says, are you examining differences between one sample and a population? This is that one sample Z test that essentially never gets used in clinical psychology research, but it's sitting right there. So just kind of be aware that it exists. So let's go up to the top. Are you examining relationships between variables or examining the difference between groups of one or more variables? And if you're examining relationships between variables, then you follow that bold gray box there to go down. Now you're in correlation land. And if it's relationships, remember it's always about relationships, magnitude, all of that, then how many variables are you dealing with? If it's just two, then you can look at the t-test for the significance of the correlation coefficient. If it's more than two, you're going to need something more fancy like a regression, which we'll cover in this class. Factor analysis is rarely used in clinical psychology or in psychological research. Canonical analysis, possibly. So just kind of be aware, those are kind of the typical things. If you have differences between groups, this is what we cover in the ANOVA t-test, what we would call the Fisher tradition. This is comparing groups with each other, the wait list or the control group versus the treatment group, that sort of thing. And that's going to be on your right-hand side. So just kind of being aware of where we sit in the larger picture of statistics. This is helpful. I'll give you one more example, and that's from my area of research, which is around family relationships. And did you know that a quality marriage does not ensure a quality parent child relationship? Now, those two things are correlated with each other repeatedly in the research. So, a more satisfying, or looking at various different quality measures of marriage and parent child relationship, that they do correlate with each other, but it's probably because they share some other construct in common. For instance, the ability to manage emotions, right? If you're able to kind of manage your emotions and to be able to be thoughtful and not too reactive, right? Emotionally, that helps you have a better marriage and a better parent child relationship. But it's not a one to one association. Some people are better at parenting than they are at relationshiping, other people is vice versa. So you really want to pay attention to what might be causing a correlation to happen, which is often some other variable. This is probably the number one mistake that I see in people doing research studies like theses and dissertations. And that is they find a correlation that is significant, but then you look at that actual correlation number and it is not too meaningful. So what'll happen is if you have a large data set, so remember back in my lectures when I talked about the law of large numbers and very large numbers, if you have a very large data set, when you run a correlation, almost everything is going to be significant at the p.05 level in your data set because you have a very large n, and that affects the outcome. And so what we do often is square the correlation coefficient so that you can look at the amount of variance that one variable or factor is determined by the other one. And sometimes you'll find that a squared correlation coefficient is only 25% of the variance, which actually in some psychological research, you'd be thrilled to see 25%. But that still means that 75% of the variance is unaccounted for. So you just need to know your area of research to know whether 25% is great or whether 25% is, what? That's terrible. Oh no, we didn't predict hardly anything, right? So you do have to understand the ability to predict another variable and that percent of variance that we're going to return to repeatedly in this area of statistical knowledge on regression and correlation. Doing a correlation coefficient is actually really pretty easy in SPSS. So I'm just going to show you a couple of dialog boxes here. You can go into SPSS under Analyze and run a bivariate correlation. And you can see here in the box, if you've got a couple of variables, they had quality of marriage and quality of parent-child relationship there on the left. You would just take those and move them over to the right. Pearson correlation is going to be already checked off. That would be your typical correlation that you would run. Typically, you're running it as a two-tailed. And if you want the significance to be flagged to tell you whether it's p.05 or if you're going to be more strict, p.01, then you can click all those things and you'll get your results. It's pretty simple. When you run your results, it's going to look like this. This is what the output looks like for correlation. Notice that you have the exact same data because it's saying what's the correlation of parent-child with marriage, and then what's the correlation of marriage with parent-child. And they're literally the same thing, right? So this one has a Pearson correlation of 0.081. That's really low, folks. When you're under 0.10, you're getting close to zero now, right? Remember that correlation runs from -1 to 1, and a perfect correlation would be 1, and a perfect negative correlation would be -1. And that means that when one goes up one step, the other one goes up or down one step, 1 point exactly. So for this, wow, 0 is perfectly random data, right? So like perfectly random data is almost impossible to find, but they got awfully close here to 0.08. So sorry, actually in their data set anyway of 36 people, which is much too small of an n to know anything, but they don't have enough power there, but still that's what they found. And then their significance was a 0.637. So of course that's also not going to be significant. Anything close to it. Do pay attention. One mistake sometimes students make with this is that they'll swap the significance in the Pearson correlation when they transpose them over onto their data, and they'll put that the correlation was 0.637 and the significance was 0.081 because you kind of expect those numbers rather than this. And so do watch and make sure you are careful with this data. Just wanted to walk through a couple things. An interesting study in 2012 looked at the relationship between those big 5 personality domains and social well-being among 236 students at the University of Tehran. So what you've got there is your big 5, if you remember what they are, right? And so I won't run through them. You can go Google it if you need to. But correlations in that study show that some of the relationship between personality factors and social well-being, particularly neuroticism, was negatively related to social acceptance, social contribution, and social coherence. So you can look at that and go, that's kind of interesting. Neuroticism is predicting social acceptance, social contribution, and social coherence. One of the questions that I have of that data is social acceptance, social contribution, and social coherence subsumed as part of neuroticism, right? Is that like neuroticism is really just an umbrella for those 3 social relationship things? People could say and argue that all day long, but that would definitely be a question I would be having for them about this. It's still interesting data to have, but it's kind of a common problem in correlational research is that you start to look at it and go, but aren't they kind of actually the same construct, or are they actually really two different constructs? And people argue about that all day, and that's what makes science go round and round. So they also found that conscientiousness was positively related to social contribution. So again, isn't social contribution kind of part of conscientiousness? I don't know. You decide. It's really something you could debate. And then the construct, the five factor construct of openness, was positively related to also social contribution and social coherence and agreeableness, was related to social acceptance and social contribution. So it's all very interesting. They ran a ton of correlations. It's a decent little study to be able to look at and understand correlations. So I find that interesting. They also looked at gender. People love to look at demographics in their studies, like gender. But then there's often questions of like, does gender matter when it comes to these things? But people do it anyway. So you hear me musing a little bit, but male students scored significantly higher than females on social well being. So is that something relevant to the students at the Tehran University? Would that be a worldwide phenomenon? Do male students just perceive themselves as more well socially, right? And female students are more nuanced and willing? Am I biased myself as a female? All of these questions are interesting real world statistical questions that you should be able to move into as a graduate student and understand and ask those kind of questions and think like this about the research that you review. In summary review, remember, correlations are powerful tools. They will tell us what direction, either positive or negative, two variables have, two continuous variables have, and they will also tell us the size of that relationship, whether it's a large magnitude or a small. Is it close to perfect or is it close to random? And we'll get a number to tell us that. And it can also help us understand what two different outcomes share with one another. So we can begin to look at, as we go through this unit, how various continuous variables can have overlapping shared variance, that sort of thing. But remember always that correlation is not causation. It only tells us about association. We can never know whether one variable affects the other, vice versa, or some third variable is affecting both of them, or in the real world likelihood, 45 other variables are affecting both of them. And all we can do is try to find some of the most important ones of all the different ones that affect us in the real world of human behavior. Thanks a lot.